Okay, so steps for solving the radical equation. First, you have to isolate the radical, so make sure it's by itself. And then you square both sides. Square is the inverse operation of square root. So that's why you do it to cancel out, and then solve for x. You do have to make sure that you check for your extraneous solutions. So remember, extraneous solutions are kind of extra solutions. They give you a false statement. When you plug it back into the original problem, it would say something like 3 equals 5. Well, 3 does not equal 5. It will never equal 5. So it's an extraneous solution. So then the answer would be no solution. Okay, so solving a basic problem like number 1, it's already, the radical term's already isolated on the left. So to cancel it out, I'm going to square it. If I square one side, I have to square the other. So now the square root squared cancel. 7x minus 18 equals 25. And then add 18. So 7x equals 43. And then divide by 7. It doesn't divide evenly, so we're just going to say x equals 43 over 7. It's fine just like that.
How did you get 20 equals 25?
5 squared is 25.
Oh, okay.
Yeah, I squared the 5. So I have x equals 43 over 7, and I have to check it to make sure it is a true solution. It might be a fake solution or extraneous. So I'm using the original problem, square root of 7, but a blank for x, minus 18, equals 5. Plug in 43 over 7. And as far as order of operations goes, a square root symbol, the radical, it is in the same level as parentheses, because it could also be written as parentheses to the 1/2 power. That's the same thing as the square root of those parentheses. That's the same. There's just 2 different ways of writing the same thing. So in order of operations, square root symbol counts as parentheses. So you do whatever's under the radical first, as if it were parentheses. Here I'm going to, the 7 and the 7 cancel each other out, so I have 43 minus 18. So that's the square root of 25 equals 5. The square root of 25 is 5, which really is 5 or negative 5, but like I said, we're ignoring the negative. We're just dealing with the positive version this time. Does 5 equal 5? Yes, it does. And you only have to check as far until you recognize it's true. If you saw square root of 25 equals 5, you could have said, yes, that's true right there. You don't have to get it down to a number equals a number, because it's just a check. So since it did check, my answer is x equals 43 over 7. All right. Number 2. The only difference here is it's not isolated. The radical is not isolated. So the first thing you have to do is subtract 1 to get the radical by itself. So the square root of 3x minus 8 equals 2. And then square both sides to cancel the radical. So 3x minus 8 equals 4. Add the 8. So 3x equals 12. Divided by 3, and x equals 4. And then you have to check it to make sure it's a true solution. In the original problem, 3 blank minus 8, and then a plus 1 on the outside equals 3. Now plugging in a 4 where x was. Like I said before, you do the radical first as if it were parentheses. So 3 times 4 is 12. 12 minus 8 gives me 4. So I have the square root of 4 plus 1 equals 3. Square root of 4 is 2 plus 1 equals 3. Yes, 2 plus 1 does equal 3. So that means that x equals 4 is the solution. And that's it. Now number 3, it works just the same. But on our 5B test, 5B, the test before last, this is probably one of the most missed questions of doing square root method, was something that looked like this. You have to completely isolate the radical, so nothing else with it. So in this one, first you do add the 64. Most people get that. And then 8 square root of x equals 64. But it's not isolated yet. It's 8 times square root of x. So before I can do that, I have to divide it by 8. This is where a lot of people lost points on the 5B test. You have to get the square root part by itself before you can continue to solve. So square root of x equals 64 divided by 8, which is just 8. And then you can square it to get rid of the radical. So x equals 64. And then check it. You have to check every single one of these. Plugging in a 64. Alright, so the square root of 64 is 8. 8 times 8 is 64. (64 minus 64 equals 0? Yes, that's true. It does. So the answer is x is 64. Alright, and then on number 4, this is where we have a little bit different. Still have to go through all of the steps to get the radical by itself on one side. Start with subtracting 7. So 4 times the square root of x equals 4. And then we divide it by 4. So the radical is by itself. Square root of x equals 1. And then square it to get rid of the radical. So x equals 1, because 1 times 1 is 1. Hold on. Oh, negative 4. I messed up. Nice. This is negative 4. 3 minus 7 is negative 4. Negative 4 divided by 4 is negative 1. And so when we square it, we want to square the negative sign with the 1. Star next to that. That right there is a clue that I'm squaring a negative. It's a clue that this is probably going to end up extraneous, but you should check them all anyway. But because I know I'm ignoring the negative part of the graph, and this is negative 1 squared, when I graph that, it would be in the y value would be in the negative. Anyway, so now I'm checking it. 7 plus 4 square root of something equals 3. I'm plugging in 1 for x. Square root of 1 is 1. 4 times 1 is 4. 7 plus 4 is 11. 11 equals 3? No, 11 does not equal 3. So that makes this an extraneous solution. since x equals 1 is an extraneous solution, and it's the only solution I got for my answer is no solution. Now, if you were asked what is the extraneous solution, then the answer would be x equals 1. So it does matter what you're being asked. Are you being asked for a solution or an extraneous solution? Most of the time you're being asked for the solution. In that case, the answer would be no solution. But in the rare case that you're asked for an extraneous solution, that would be x equals 1. But that's solving square root equations. So like I said, this shouldn't be too strange because of all the time we just did spend solving using the square root method. It's the same thing. So I'm isolating the radical by subtracting the 5. So square root of x plus 7 equals 10. Square both sides. So x plus 7 equals 100. Subtract the 7. X equals 93. Alright, so x equals 93. Check it.
Easier for you to pass.
Thank you. Check it in the original problem. 5 plus square root of something plus 7 equals 15. Plug in 93. So I have the square root of 93 plus 7. That's the square root of 100. Square root of 100 is 10. 5 plus 10 equals 15. Yes, it does. So x equals 93 is the solution. Alright, so that is as far as I'm going to go on this. There's nothing really different about the last example. I'm going to leave you here.